Hey everyone, I'm Alexander Mattoni, co-founder and head of engineering at Cycle.io, and today we're going to be chatting with Kyle Galbraith over at Depot.dev about how to optimize and improve your Docker file build speeds. So stay tuned, we're going to dive right in. Hey Kyle, thanks for joining me today. Good to have you on. I just wanted to have a great conversation about optimizing Docker files, and I think you're a guy with a lot of expertise in that area, so would love for you to introduce yourself and tell us who you are.
Yeah, awesome. No, thank you for having me. I'm Kyle Galbraith. I'm one half of the co-founding team of Depot. Depot really got its start in accelerating Docker container builds. We have effectively focused on this idea of what if we ran build kit up on cloud VMs and attached persistent caching to those VMs and orchestrated layer cache across builds. And nowadays, it depots that plus a bunch of other features such as native multi-platform builds for Intel and ARM, detailed build insights to debug your Docker image builds. And we also offer depot managed GitHub action runners now.
Awesome.
So, yeah.
Cool. And over on my side, I'm head of engineering, co-founder here at Cycle, and we do DevOps, just pretty much everything around DevOps, from the importing of your images to putting them across multi-cloud infrastructure and managing and making sure they stay online. So it made sense for us to have this call, I think, because we're both interested in Docker images that run well and perform well, because the faster you can get them up online, the better it goes. And I think you guys are experts in that area.
Yeah, no, definitely. We've been focused on this problem of Docker image builds for over 2 years now. And then throughout our careers for roughly the 6 years that we've been working together at two different companies. So we've become very intimately familiar with Docker image builds, Kubernetes, container orchestration, all of those things.
Gotcha. So, in your opinion, what are some of the most important things that people can do to speed up their Docker files and make sure that their build process doesn't hinder their actual development?
I think it really comes down to three things. So there's effectively like know what is in your Docker image. And what I mean by that is both what is in your build context, um, as well as what is in the base images that you're using. So your build context is really if you run Docker build or Depot build, and you do Depot build from your current directory or Docker build from your current directory, that is sending up everything that is in that current directory as your build context to a given build instance, whether it's Depot or Docker. And where a lot of people go wrong initially there is they either don't have a Docker ignore, they don't have important folders and directories in their Docker ignore, things like that. And the reason that can bite you is effectively anything that you send up in your build context. If you do a copy dot to dot, you can end up copying a bunch of irrelevant files into your final Docker image. Then on like the base image side, it's really knowing like what's in your base image. So uh, this this story goes back for many years now. Of wow, a Docker container just allows me to like ship my development laptop to production.
Hmm.
Sounds great in practice. Terrible idea in
Absolutely.
general. Yeah.
I would say that that's probably one of the number one reasons we started building Cycle too, is because we saw the magic of Docker and the Docker files and running them locally. We're like, wow, for local development, this is awesome. This works great. The second we tried to put that into the cloud, all hell broke loose, so to speak, and it was really difficult to take that magic and capture that magic in the cloud. So I totally see where you're coming from. And regarding the context, I think the first time many years ago when I built my first Docker image, I think I'm mainly, I work a lot in Node, and I think I copied into some 14 gigabyte context at some point, and I thought, this is ridiculous. Why is this taking so long? So once I learned the magic of Docker ignore, I was able to copy in more like a 4 megabyte context, which I think is a little bit more appropriate, but definitely depends on the language and things that you're using too.
Yeah, when it comes to build context, that's definitely one of the biggest gotchas that we see with Depot is because Depot is a remote container build service. So your build context has to be transferred up to Depot. Your entire build context on the first build has to be transferred up to Depot. And a lot
Oh
of
wow.
people will miss like basic things of like ignoring node modules or ignoring like dependencies, things like that. And so all of that gets transferred up. Build context is also has slickness to it in that it syncs essentially. So if you run another build after that first build, it's not like your entire build context goes up to a builder again. It's only the files that changed. But if you're doing node stuff and you're constantly touching npm in your node modules, you're always going to be sending up your node modules, which is a nightmare.
Oh yeah, absolutely. I was recently dealing with. Well, I see a lot of people who come to Cycle and ask for some tips and tricks on improving some Docker files too. And one of the things I see a lot is people will, instead of doing the builds inside the actual container, they will do all their npm stuff and then just copy in their node modules folder, copy in their
Mm-hmm.
executables or whatever, and package that up and send it off. So I was wondering if you had any thoughts on why that might actually not be the greatest move.
It's not a great idea, because if you do an npm install outside of your Docker container, you're kind of going around the entire point of a Docker container. So if you do an npm install, I think what a lot of people don't realize is some node libraries can use native operating system dependencies, right? So if you do that from your machine and then copy your node modules into a Docker container, well, the npm install that you ran on your local MacBook might not match the npm install that you actually need to do inside of a Ubuntu container. I think there's languages where that's a valid path. So you see this a lot in like Goland. People will do things like this, and a little bit in Rust. It too has like the same kinds of disadvantages. It just has a smaller blast radius.
Mm-hmm. Yeah, well, I think it's pretty immediate to know when you've used the wrong architecture and you're trying to run it on, a cloud x86 machine, but you built it on your M1 Mac, which is using the ARM architecture. So, but with Node, I think it's a little more sneaky. We get some pretty arcane and hard to interpret
Mm-hmm.
errors when you're running into those kinds of things that can lead you down a rabbit hole. And then again, the Node module ecosystem can be a little bit like that, no matter what you're doing. So.
Yep, very true.
And then on Cycle, one of the things that we need to concern ourselves with quite often is, the speed of being able to transfer it to many different many different nodes all at once. And so one of the tricks that we employ is, since our assumption is that the images that we're receiving are production ready, we actually flatten out the layers from that to make the images a little bit smaller, a little bit more portable for us to be able to use, because we don't really care about reusing the cache at that point. But I did want to talk a little bit about the layers themselves. Cycle stripping them out for the deployment for ease of transport, but for what you guys are doing, I think those are pretty important to maintain and actually get correct in your Docker file.
Yeah, Docker layer caching is one of the fundamental problems that led us to build Depot. Is effectively layer cache is your previous build results. So if you're using Docker locally, you run a Docker image build, it builds, you run a Docker image build again, you get to reuse some of those results. When you go into something like GitHub Actions or Circle CI or something like that, what ends up happening is you're on an ephemeral runner. So like you don't get the same disk, you don't even get the same runner across multiple builds. And so you have to save this Docker layer cache over networks off of the ephemeral runner, and then effectively like reload it on your next build. But Docker layer cache can be tens of gigabytes in size, because I think what a lot of people don't realize is a Docker layer is effectively the previous layer plus whatever you changed in that run statement or whatever Docker file statement that was ran. Um, and so it's effectively like each layer is a version of the file system with the changes applied. So there's a lot of advantages to compressing it all down to one layer. I imagine you guys see a lot of performance benefits from that because you effectively remove duplicate file system things. Um, but with Depot, effectively what we do is we flip that CI problem that I was speaking about, and we turn it on its head, and we say like, okay, you still have an ephemeral builder, but we orchestrate the cache around you. So we persist the layer cache to a real NVMe drive, and then just automatically reattach it to your next build. And so effectively you get the local Docker build experience, but in CI with super powered build kit builders that we offer.
And when people are building their Docker files, are there any things that they should really keep in mind when it comes to layering? I know it probably is going to depend on the language that you're actually building these things
Hmm.
in because I think everything's a little different, but just any general, guidelines to follow.
Yep, I would say order matters a lot. So I think the most common example that you see is people doing like copy from my current directory into the working directory, then run npm install. Well, that's not good because anytime a source code change happens, you're going to have to like reinstall your dependencies. And something like npm, that's like pretty expensive. So what you should do instead is just copy in just the things that you need to do the npm install. So to use the npm example, you're copying your package.json and its lock file. You would run npm install, and then you would copy in your source code. And what that does at like a Docker layer cache level is effectively you can now cache that npm install. And as long as your package, as long as you don't install a new package version or install a new package in general, then that cache layer won't invalidate. And so you can reuse it across builds.
Gotcha. Yeah, and I think that kind of leads us into the next major thing, which you just recently wrote an article on, which is going to be the multi-stage builds. And so, just curious on your take on how all of how do multi-stage builds kind of fit into the caching layering concepts we just talked about.
Multi-stage builds are a way to like split out the different, what I would call like core cycles to force a pun here, the core cycles of your build out into different stages. So effectively, that dependency step, you can move into a dependency stage inside of your Docker file. And then you could have a build stage where you actually like build your static assets. And then your final stage, you just copy from the dependency stage and your build stage the things that you need into that final image. And that has a lot of like really interesting benefits, both from like a Docker build perspective, but also from like a run perspective. So when you use multi-stage builds, each stage can be built in parallel. So common misconception with just a basic Docker file, if you go from the top to the bottom, no multi-stage, that will run serially. So it will do one line, then it'll do the next line, then it'll do the next line, because that's how Docker files are constructed. They're hierarchical. So you can't actually compute the child until you know the parent. But when you do a multi-stage build, you essentially get parallelism. So you can build the different stages in parallel until there's like in your final stage, I need to copy from this uh, stage above me. Then build kit will block and wait for that. And then on the actually running the container side, um, when you copy files from an earlier stage into your final image, you're only copying those files. And then the rest gets thrown away. So the rest is not in your final image size, which is really important when you get into talking about 10s,
Yeah.
20, 30 gigabyte images.
Are 10, 20 gigabyte images something that you actually commonly see, or
Oh yeah.
really?
I think the largest we've seen with Tipo to date is probably somewhere between 60 and 75 gigabytes.
Oh my God.
I think this is one of the things that we learned with Tipo that we never foresaw early on. I don't think anybody like really foresaw the whole AI LLM boom like taking off. We certainly didn't. But as it took off, it became clear that people were packaging up these big LLM models into Docker containers because that's kind of become this like standardized way of deploying applications and services. And so they're applying the same process to these new types of applications and services. And frankly, like some people that are building those on Depot, they can only build them on Depot.
Right.
Like they can't build them locally. Like they don't have enough disk space to do that or enough compute power.
I often have to run the Docker system prune command to eliminate what apparently is, 200 gigabytes of build artifacts that are sitting around on my machine all the time. That I
Yep.
was so happy when they introduced that command because I didn't realize I'll often get like out of disk space on my Mac, and I'm like, oh, I guess it's just time to run Docker prune, and then all of a sudden I've got 80% of my disk space back and available to me. So I can't imagine if you're doing LLMs, that must be insane. I get a
Hmm.
heart attack if my image is over 500 megs. But of course, with Node, smallest you can get is about 300, maybe if you're trying
Yep.
running on Alpine.
And I
So
think 300 with Alpine is about as low as you can get. Yeah.
yeah, yeah. And you know, this is also I think why you know, we recently partnered together and we did a Depot integration into Cycle, and I think it made a lot of sense because you know we have a lot of people who are doing large language models and all of these uh, uh, different things now around AI since it's kind of taken off. And they had the same problem is when Cycle comes in and it's stripping out those final layers and everything using our normal build process. You know, you could get builds that would take, you know, hours sometimes going through this process. And so I think, you know, by integrating with Depot, we were able to, you know, kind of get the best of both worlds. You guys handle the layer caching in the cloud side of things, and we get the final image, that final stage out of there that we can distribute rather, you know, easily, comparatively speaking.
Yeah, I think it's been great from our side too. Is there's a lot of folks that want out of the Kubernetes world, but they want like that experience. And so a lot of tooling is like built around this idea of like I'm going to build a container and then it's going to go to a cluster. And so I think a lot of people are very hungry to like go to this world of I don't have to manage cluster. I just plug into Cycle. Depot takes care of my builds. My applications and services are running inside of my compute environment. And that has a lot of advantages, both from like a business and tech perspective.
Yeah, I think having the the managed aspect is something people are kind of craving today. The managed, but I have full control over everything if I want to open up that hatch and go deep. And I think that's where we really sit. Um, let's see. So I guess anything else that you want to add to some of this stuff? I think we kind of covered some of the basics on simplifying your Docker files, but anything else that you can think of?
I think some of the other things that we often talk to people about is some of the unsung features around BuildKit and Depot's optimized version of BuildKit, which is really like where you get into how can you optimize a container image for starting up. So this is where things like eStarGZ, Nidus, I forget what the Amazon one is, but there's an Amazon one. These are effectively manifest files inside of your Docker image that allows an orchestrator to lazy load the image. So this becomes particularly relevant the larger and larger your Docker image gets. So if you are going to be building 20, 30 gigabyte images, you should be building them with eStarGZ enabled so that when you do go to run them in whatever compute environment, um, you can effectively lazy load the image so that it starts up quicker. I think that's one of the things that we're looking at into like adding into our own lint rules and things like that inside of Depot to help folks essentially pinpoint when they should be using that. And then even going as far as turning it on automatically for them.
Mm-hmm. Awesome. Yeah, I haven't really explored too much on the 30, 40 plus gigabyte image side of things, so that makes a lot of sense. One of the tricks I do like to do, taking advantage of BuildKit, is you know when you're doing multi-stage builds, targeting specific builds when I want to do specific things. So
Mm-hmm.
this is something that's really cool because when you have these different stages in here, if the one that you're targeting is not, you know, it's got other stages that are not necessarily in that path to be able to build it. BuildKit just ignores that stage pretty much completely. It doesn't actually make it into the layer caching.
Mm-hmm.
And so I like to do that for if I'm targeting for testing or something like that. I can use one Docker file, but build, you know, 2, 3 different images, one for, you know, testing, development, other things like that. And then I can also have my final prod image in there and then just switch the target command on that. Is that something you see people doing or?
We see that with very large mono repos.
Mm-hmm.
And I will say that like I think I've seen a 1,000 line Docker file
Oh,
with Depot,
wow.
where effectively they were using like one Docker file and they were using the stage trick to like build for specific applications. Um, that works. I would think there's a bet. I would say there's probably a better way of doing that, but if that works, go for it. I think the other thing that we see most often with Depot is folks switching to Bake. So if you're not familiar with Bake, Bake allows you to represent multiple Docker image builds inside of an HCL file, or you can even use a Docker Compose file. And so what happens there is effectively you can define your 5 Docker image builds inside of one HCL file for the 5 apps inside of your mono repo, run depot bake, give it that file, and all 5 of those images get built in parallel and
Oh,
then
cool.
pushed in parallel as well. So that's particularly relevant to folks that are doing mono repo things. Yeah.
Awesome. Well, I think that's all from my side today, Kyle. I appreciate you coming on and chatting with me today. And we'll be talking soon, I'm sure.
Awesome. Thanks for having me. It was great chatting.
Yep. You too.
Cheers.